Despite being out of favor since the 60s due to its inferior strength-to-weight ratio compared to other materials like carbon fiber and aluminum, why did SpaceX choose to build their 100-passenger Starship with stainless steel? In today's video, I'm going to share with you why SpaceX built a stainless steel Starship instead of using common, lighter materials like carbon fiber or aluminum alloy used for their other spaceships, including their most popular Falcon 9. Before we move into the main thing, don't forget to subscribe to our channel, Futurephile, to get hard-to-find information and facts about futuristic technologies and innovators. Now, when building an interplanetary spaceship such as the SpaceX Starship, one of the critical factors that has to be considered is the overall weight of the vehicle. The lighter, the better. That's because every extra ounce of weight adds to the amount of thrust needed to lift the ship off the ground, and it also makes a huge difference in the ease through which the ship will break through the Earth's atmosphere, which may mar the success of a mission. So, why did SpaceX choose to use the much heavier stainless steel instead of the much favored lighter materials, such as carbon fiber and aluminum? That can be answered in two words: cost and performance. Well, to start with, let's talk about the most obvious factor, which is the cost. When starting a private business, which of course SpaceX is, to make profit, one of the critical factors you have to make sure you get right is keeping costs low as much as possible. When you compare the cost of carbon fiber to that of stainless steel, the carbon fiber costs a whopping 60 times more than the stainless steel. 1 kg of carbon fiber cost around $180 to $200 after 35% of the material has been scrapped off. Now, compare that to the stainless steel, which costs just $3 per kilogram. That's such a great saving on production cost. And not only that, another great thing about stainless steel material is that they are so easy to work with and already well known, which means the SpaceX engineering team doesn't have to wait a long time for materials or go through some unnecessary complex procedures to work the materials. They can easily get what they need since stainless steel material is readily available. Start working immediately and have higher chances of reaching their lofty goals of sending around 1,000 starships conveying passengers to Mars by mid-2020s. The second factor behind the use of stainless steel is the superior performance of the material under intense freezing and heating conditions compared to other available materials. You see, for a Starship that's built to go to Mars and back, there will be a lot of subjection to high levels of temperature change, both cold and hot. For a material such as aluminum, when subjected to temperature greater than 150 degrees Celsius, which is the same as 300 degrees Fahrenheit, they start to brittle, they weaken and deform. That melting point is way below what is required for the expected peak heat a Starship will be subjected to when re-entering the Earth atmosphere, which can go as high as 1,500 degrees Celsius. However, compared to stainless steel, which has a high volume of chrome-nickel content, it gets 50% stronger in cold conditions and can withstand tremendous amounts of heat, around 870 degrees Celsius or even higher. Now, that's a great difference from the aluminum's 200 degrees Celsius. More so, stainless steel has a shiny surface, which will help reflect a good amount of radiant heat instead of absorbing them. Which is a good thing, considering the fact that the stainless steel Starship will have a very few forms of heat shielding protection. While the 870 degrees Celsius and the shiny surface are good properties, they're not enough. It still falls short of what is required to withstand the expected 1,500 degrees Celsius re-entry heat. However, that won't be a problem when you consider the fact that SpaceX is looking to complement that by developing a form of regenerative heat shielding mechanism, which works just like the way the human's temperature regulating system works: sweating. That may sound outrageous, but this is basically how it works. Under the outer layer of stainless steel is another, but this time, better stainless steel, which is capable of withstanding even higher temperature. In between both layers of stainless steel will be methane, which will be released gradually through the tiny pores that will be all over the outer layer stainless steel. As the Starship re-enters the Earth atmosphere and the heat increases due to drag, the methane will be released, which will soak up the drag heat, turn to gas, and evaporate into the atmosphere. I think that's a brilliant way of solving new problems with old but improved methods. What do you think? You think it's a great idea SpaceX ditched the original planned carbon fiber for the stainless steel? Do you think the whole thing will work? Share your thoughts in the comments below. And if you like this video, you may also enjoy our full playlist on SpaceX. See you in the next video on the playlist. And hey, don't forget to subscribe to our channel. Thank you.